Welcome to the AICTE approved faculty development program. The title is Use of ICT in Education for Online and Blended Learning, run by IIT Bombay. This is the term and assignment by Maulin Joshi. The subject is Digital Electronics and the topic is Introduction to Boolean Algebra and Simplification. At the end of the lecture, student will be able to explain the basic operations and the laws of Boolean algebra. Also, they will be able to explain and express the output of a circuit using Boolean algebra. This is our lecture plan. We'll first discuss about the Boolean algebra. We'll see the Boolean operations, laws of Boolean algebra, and then couple of review questions. Boolean operations, we start with the defining the terms variable, complement, and the literals. A Boolean variable is a symbol used to represent a logical quantity. Any single variable can have 1 or 0 value. Complement is the inverse of a variable and is indicated by the bar over the variable a bar, or the other way as complement a complement. If a is equal to 1, then a bar is equal to 0. If a is equal to 0, a bar is equal to 1. A literal is a variable or the complement of a variable. If we start with the Boolean operations, the first one is addition. Boolean addition is equivalent to the OR operation. In Boolean algebra, the sum term is a sum of literals. Some of the examples are a plus b, a plus b dash plus c, and a plus b plus c dash plus d dash. A sum term is equal to 1 when one or more of the literals in the term are 1. The sum goes to 0 only if each of the literal is 0. The second operation is multiplication. Boolean multiplication is equivalent to the AND operation. In Boolean algebra, the product term is the product of the literals. Again, let us see some of the examples. AB whole bar, A B bar C, and A B bar C D bar. A product term is equivalent to 1 only if each of the literal in the term is 1. A product term is equal to 0 when one or more of the literals are 0. Laws of Boolean algebra. The basic laws of Boolean algebra are commutative law for the addition as well as multiplication, associative laws for addition and multiplication, distributive law are the same as the ordinary algebra. Commutative law. The commutative law of addition for two variables is written as a plus b, that is equal to b plus a. This law states that the order in which the variables are odd makes no difference. In Boolean algebra, as applied to the logic circuits, addition and the OR operations are the same, and this symbol means equivalent to. A or B, it can be written as A or B, it is equivalent to B or A. So this is the figure for the application of the commutative law for addition. Commutative law for the multiplication in the similar way can be defined as A dot B is equal to B dot A. This law states that the order in which the variables are ANDed makes no difference. So if we can take first A and B, this is the AND gate. So the answer is AB, which is equivalent to if we take B first and then A, resulting into BA. Associative law. The associative law of addition is written as A plus into bracket B plus C bracket over is equal to into bracket A plus B bracket over plus C. This law states that when the ORing for more than two variables, the result is the same regardless of the grouping of the variable. That means if we do the ORing of B and C resulting into B or C and then we add A, that results as A plus B plus C, which is equivalent to if we first OR A and B resulting into A or B and then ORing C, that results into A or B or C. So associative law says that there is no difference as far as these associations are concerned. The associative law of multiplication in a similar way is written as A dot B dot C, that is equal to into bracket A dot B and the answer's multiplication to C. This states that when the ending for more than two variables, the result is same regardless of the grouping of the variable. So that is B, C and then ending by A, that is equivalent to first finding out the AB and then ending with C. Distributive law. The distributive law is written for three variables as follows: A into bracket B or C, that is A into B plus, that is or A into C. This law states that ORing the two or more variables and then ending, so that is this, ORing these two and then ending is equivalent to ending first and then ORing. In the figure we can see that B or C and then end. So that is answer X, which is equivalent to first ending, that is AB and AC, and the answer is OR then after. These are the few review examples. Determine the values of A, B, C and D that make the sum A plus B dash plus C plus D dash equal to 0. So you need to select the values of A, B, C, D so that the answer becomes 0. Similarly, for the AND operation, determine the values of A, B, C, D that makes the product term A, B dash, C dash, D equal to 1. Thank you for listening to the lecture.